So we are recording at this time. If you talk, you'll be recorded. So just making you aware of that. So last time we were working in section 9.1. We had gotten almost through it. We just have the practical applications to look at. Okay. And so the practical applications are going to involve finding like surface area or volume or something like that. And usually we're going to have to do something a little bit more than that, like maybe find like how many cubic feet of concrete's involved, or like how many gallons of water could fill up a tank or something like that. Okay, does that make sense? So example 4. But before I do that, we had talked about like some different conversion rates, and we could find other conversion rates as well. Okay. Anyway, example 4. Lewis and Clark Construction Company must pour a concrete foundation 3 feet deep for a building with outside dimensions of 56 feet by 28 feet. If the walls are to be 8 inches thick, how many cubic yards of concrete will be needed for the foundation? Okay. Now, one thing that we have to be careful about here is that there's a mix of units. Okay. So first of all, we know that this foundation has to be 3 feet deep. Okay. If you look at the figure here, the dimensions are 56 feet by 28 feet. So all of that's in feet. Okay. But it's 8 inches thick. Okay, so there we've got a different unit. And the question was, how many cubic yards of concrete would need to be purchased? So we've got to, take care of the units there as well. Does that make sense? Okay. So before I worry too much about the units, I just want to think about the shape that we have here. Okay. So, it's like we've got a rectangular prism, but we've got the inside cut out, right? So we need to figure out the volume of this thing. Well, one way that we can figure out the volume is to think about like the base of this. Does that make sense? Okay. So I could find like the area of the outer rectangle and subtract the area of the inner rectangle in order to have the area of the base. And then if I take the area of the base times the height, that will give me the volume. Okay, does that make sense? So, but if I'm going to find, say, the volume, then I've got to decide what units I'm going to use, okay? And since almost everything here is in feet, probably the simplest thing for me to do is to find the volume in cubic feet, and then once I know that, convert to cubic yards. It would also be possible to change this to yards, this to yards, this to yards, this to yards, and just do it all in yards in the first place, okay? Does that make sense? But I think I'm going to do it, find the volume in cubic feet. And then once I know how many cubic feet, I will use this to figure out how many cubic yards. Does that make sense? Okay, so that's my plan. Okay, so the first thing I'm going to do is find the area of the base. Okay, so now again, looking at my base, it's 56 feet here by 28 feet here. That's pretty easy to find, just 56 times 28, and that'll be square feet, okay? But then I'm gonna have to subtract out the inner area here. And so how am I gonna do that? Well, if I think about this, like from here to here is 8 inches, and from here to here is 8 inches. Okay, does that make sense? Now 8 inches and 8 inches is 16 inches, and 16 inches divided by 12, that's 1 1/3 feet. Does that make sense? 1 1/3 foot, I guess I should say. Okay, so if I take off the 1 1/3 foot from the 56 feet, 56 minus the, minus the 1 1/3 is going to be 54 2/3. Whoops, you can't see that, can you? Okay, so 54 2/3. So that's going to be the inside rectangle's length, let's say. So that's going to be 54 2/3 feet. Okay, make sense? And then the same idea over here on the side. Here I'm going to take off 8 inches, and here I'm going to take off 8 inches, which again is 1 1/3 feet. Okay, you follow me? That's 16 inches, which is 1 1/3 foot. So if I take 28 minus the 1.3 repeating, that's going to be 26 2/3. So, well, my picture here is not very good, but that side right there is 26 2/3 feet. Okay, does that make sense? So my area, I'm going to say the base area is going to equal 56 feet times 28 feet minus the inside, which is 54 2/3 feet times 26 2/3 feet. Does that make sense? Okay. So put that over here again so I can read it. So 56 times 28, that's going to be 1,568, and I'm going to say square feet there, minus, now 54 2/3, I'm going to just do this in decimals, okay? We're going to ultimately use decimals anyway. So 2/3 is 0.6 repeating. So 54.6 repeating, I'm just going to repeat that, 8 or 9 times, okay? Times 26.6 repeating, that's going to be 1,457.7 repeating. And so if I take 1,568 minus that, that is 110.2 repeating square feet. That was square feet there as well. Does that make sense? So the area that you can see in blue right there, that is 110.2 square feet. So and the 0.2 repeating is really 2/9. Okay, still with me? So if I want to find the volume of the foundation here, I can take that area times the height, the altitude. Okay, so the volume is going to equal the 110.2 repeating square feet times the 3 feet, which is the depth or the height of that foundation. Okay, so if I just take the 110.2 repeating times 3, that's going to be 330.6 repeating, which is 330 2/3. Okay, so this is equal to 330.6 repeating. And now that's cubic feet. Again, square feet times feet will be cubic feet. Okay, or it's volume, and volume is going to be in cubic units. Okay, so that's how much concrete I need. I'm going to need about 331, not counting waste or anything like that, about 331 cubic feet. Okay, but again, the problem wants to know how many cubic yards of concrete. Concrete's typically sold in terms of, they call them yards, so it's cubic yards. That has been changing lately, and they have been using cubic feet instead of cubic yards. Sounds cheaper if you're selling a smaller part, okay? Anyway, we want it in cubic yards. Well, we know that 1 cubic yard is equal to 27 cubic feet, okay? And that's because if you think about a block, like a cube that's 1 yard long, it would be 3 feet by 3 feet by 3 feet. So 1 yard by 1 yard by 1 yard is the same as 3 feet by 3 feet by 3 feet, and 3 times 3 times 3 is 27. So there's 27 cubic feet in 1 cubic yard. So if I convert this, okay, so 1 cubic yard is 27 cubic feet. So in other words, if I take the 330.6 repeating and divide that by 27, that is about 12.25 cubic yards. Does that make sense? It didn't say specifically in the example where to round, so I'm going to round that to 2 places. So about 12.25 cubic yards of concrete would need to be ordered. Now, again, that's not taken into consideration like spillage and waste and so on. So you'd probably want to order a little bit more than that. I'm not sure how much more, maybe like an extra cubic yard. So maybe like 13 cubic yards or something like that, just to be safe. Okay, does that make sense?
Do you have more of these notes?
I think, and I should warn you, I am recording. So if you talk, you'll get recorded.
Okay,
Just so you know, don't want
that's all right.
to illegally record you.
I didn't see them on the.
I think I put them up, but I put them up late. I didn't have them done so I only put them up a week or 2 ago. So
Oh,
if you haven't checked within the last week or 2, they are there. Okay. Any questions about example 4? Okay. So, and by the way, this camera right here, if you talk, it's like motion sensitive, so it will turn and put you on the camera, just so you know. I mean, you won't see it turn, but like inside there, it'll turn. So just so you know, you could be, your image could be recorded too, just so you're aware of it. Okay. Example 5, similar to example 4, sorta, but a little different. First of all, in the shape, and we're going to be looking at like amount of water that it would take to fill up a surface or a pool in this particular case, rather than like concrete. Okay. So example 5. How many gallons of water are needed to fill the swimming pool shown? Round to the nearest whole gallon. Okay. So this is a fairly sort of typical looking pool. Okay. Again, I want to point out that on these application problems, you have to pay attention to the units. Okay. Because sometimes they're mixed up. So like, for example, 3 feet, 12 feet, 12 feet, 11 feet, but 25 yards. Okay. So we got to pay attention to the fact that we've got a mix of units there. So essentially what I need to do in order to figure out how many gallons of water it would take to fill up this pool is I need to find the volume. And then once I know the volume, I can convert that to gallons using, what I know up here. Okay. So like, for example, up here, I know that 1 cubic foot is about 7.48 gallons. So if I were to find the volume of the pool in cubic feet, then I could convert to gallons pretty easily. Make sense? Okay. So first thing I want to do before I forget, we have 25 yards, which is the length here. Okay. So I'm going to change that to feet. Now there's 3 feet in a yard. So if I take 25 times 3, that would be 75 feet. Is that okay with everybody? Okay, so now everything's in feet. Okay, now I want to find the volume of the pool. So to find the volume, I need to find the area of the base and then take the base times the altitude. Okay, so in this particular case, we have a prism here, but this is a trapezoidal prism. Okay, now it's kind of sideways, right? Because it's a pool, but we have a trapezoid. Okay, so if I can find the area of the trapezoid, and if I then multiply that by the altitude, which will be 12, that'll be the height, so to speak, if it was laying normally. Does that make sense? If it was standing up, like most of the figures we think of when we look at the formula, you'd have the trapezoid at the bottom and the top, and then the altitude would be 12 feet. Does that make sense? So I'm going to find the area of the trapezoid. Okay. And remember, how do we find the area of a trapezoid? Is that okay? And the trapezoid that we have in this particular case, I'm going to kind of draw it more like I normally think about trapezoids. It's kind of like this. Okay. You with me? So base 1 is going to be the 3 feet right here. Base 2 is going to be the 11 feet right here. And the altitude of the trapezoid, or the height of the trapezoid, is going to be the 75 feet. Does that make sense? Okay. And these are right angles. So the 75 feet is the height. Okay. It's one of the sides, but it's also the height. It's a right trapezoid. Okay. So my area is going to be base 1, so 3 feet, plus base 2, 11 feet, divided by 2. And then that's going to be times the 75 feet. Is that okay? Now 3 plus 11 is 14, and 14 divided by 2 is going to be 7. You follow me? So inside the parentheses, I really have 7. So this is going to be 7 feet times 75 feet. And 7 times 75 is 525. So we have 525 square feet. That's the area of the trapezoid. Make sense? Okay. So the volume of the pool is going to equal the area of the trapezoid times the altitude. And again, the altitude in this case is the 12, like the width of the pool. Does that make sense? Okay. So that's going to equal the 525 square feet times the 12 feet, which again is the width of the pool. Okay. So 525 times 12, that is 6,300. So 6,300 cubic feet. Cubic feet because it's volume, or square feet times feet is going to be feet cubed. Everybody, you good? Okay. So now if I have the volume, if it's 2,300 cubic feet, I want to know how many gallons. So I just need to convert that to gallons. So again, if I look up here, I know that 1 cubic foot is equal to 7.48 gallons. So about 7.5 gallons. Okay. So I have 6,300 cubic feet. And again, I know that there's 7.48 gallons in 1 cubic foot. So that's going to cancel out cubic feet, and that will give me gallons. So 6,300 times 7.48, that's about 47,124 gallons. Does that make sense? So if you want to fill up your pool, it's going to take about 47,000 gallons in order for you to do that. Okay. Is that horrible? Example 6. 1 gallon of paint will cover 400 square feet of surface. How many gallons are needed to paint the outside walls of a building that's 26 feet high by 42 feet by 28 feet if there are 480 square feet of windows? Assume you cannot buy a fraction of a gallon. So you got to buy whole gallons, right? You can't go to Lowe's and buy, 0.6 of a gallon. Okay. You got to buy whole gallons. You could buy half gallons and quarts and so on, but we're going to buy as many gallons as we need. Okay. So the first thing that we have to do is kind of wrap our head around the problem here. Okay. So we know that 1 gallon of paint will cover 400 square feet. Okay. And we have an outside wall of a building, and the building is 26 feet high. Okay. And it's 42 feet by 28 feet. Okay. So picture that. So like, here's our building. My picture is not the best in the world, but here's our building. Okay. So it is, again, 26 feet high. And the building is like 42 feet long and 28 feet wide. Does that make sense? Now, we're just going to paint the outside walls, right? So I need to paint this wall, there's this wall on the back side, and there's this wall on the left side. Does that make sense? So in other words, I'm going to paint the lateral surface area. Okay. So I'm really needing to find the lateral surface area. Okay. But as an added complication, there's windows. Now, it's nice enough in this problem to tell us altogether there's 480 square feet of windows. Okay. So like, picture it, there's windows, and so on. So you don't paint the windows, obviously. So you don't need to buy paint to cover the windows. Okay. So altogether, if you add up the area of all the windows, that's 480 square feet that we can take off that we're not going to need paint for. Does that make sense? Okay. So you remember how to find the lateral surface area? The lateral surface area is equal to the perimeter of the base times the altitude or the height. Is that okay? Now the perimeter of our base, well, the base is going to be this rectangle that's 42 feet by 28 feet. So the perimeter is going to be 42 plus 28 plus 42 plus 28. Does that make sense? Okay. So P is equal to 42 plus 28 plus 42 plus 28. So that's 140. So the perimeter is 140 feet. Okay. So my lateral surface area is going to be 140 feet times 26 feet. Okay. So that is 3,640 square feet. Y'all with me? Okay, not too terrible. Now, again, that's including the windows. Okay, but we don't need to paint the windows. So the amount, the area that I'm going to paint, so I'm going to say the area to paint is going to equal the 3,640 square feet minus the 480 square feet of windows. So that is 3,160 square feet that we need to actually paint. You okay with that? Okay. But my question is, how many gallons of paint do I need to buy? Okay. Well, again, we know that 1 gallon of paint will cover 400 square feet of surface. Okay. So if I will take my 3,160 square feet, and if I'll just multiply that by 1 gallon is going to cover 400 square feet of surface. So in other words, I'm really going to divide by 400. Okay. So if I divide by 400, that's going to be 7.9 gallons. So really, I need to buy 8 gallons. Okay. So we need to buy 8 gallons of paint. Does that make sense? It's not too horrible, right? I mean, essentially, we're just finding the lateral surface area, and it doesn't tell you that in the problem, right? So you got to think your way through that. You got to find the lateral surface area, take out the windows, okay? And then use the fact that in this particular paint, 1 gallon covers 400 square feet, okay? Now, I do want to make it clear, that's not an absolute conversion fact, right? Okay. Different paints may cover more or less surface. Okay. So for this particular paint, 1 gallon will cover 400 square feet. Okay. Unlike 1 cubic foot always equals 7.48 gallons, right? That's definite. Okay. With paint like this, that's not definite. Last problem of this section, same idea. We want to find the weight of the steel V block shown below if the density is 0.01973 pounds per cubic centimeter. Okay. So what's density, first of all? Density is like weight per volume unit, per unit of volume. Okay. So in this particular case, for every cubic centimeter of volume of this particular metal or steel, it weighs 0.0173 pounds. Does that make sense? Okay. So density is just like a weight per unit of volume. Okay. So for this, again, if it's a different type of steel, it will have a different density potentially. Does that make sense? Like if this was lead, it'd be a lot heavier. Okay. Does that make sense? Instead of steel. So it's how much the density of something's how much it weighs per unit of volume. Okay. So essentially what we need to do is we need to find the volume of this steel V block. And then once we know the volume, we can use this density to figure out how much the block weighs. Does that make sense? Okay. So how do I find the volume of that V block? Well, volume is the base area times the altitude, right? So though it doesn't particularly look like it the way it's laying here, this is a prism. Okay, this is a right prism. So if I can find the area of the base, and if I can find the height or the altitude, then I can use that to figure out what the volume is. And then once I know the volume, I can use this fact to figure out the weight. Okay, does that make sense? Okay, so now again, this is like a prism that's laying on its side. So the base is this shape, you know, here on the end. So if I draw that, that's the base. Is that okay? And then the height's going to be the 48 centimeters. Okay. So I've got to figure out the area of this base. And then once I know it, I'll take it times 48. That gives me the volume. And again, once I know the volume, then I can use this to find the weight. Okay, which is what we want. Okay, so would you agree that looks like a rectangle with a triangle cut out of it? Okay, so I could find the area of the rectangle, find the area of the triangle, subtract those two, and that's the area of the base. Okay, and then again, once I know that, I'll take that times the altitude, 48, and that'll give me the volume, so I can then find the weight. Okay, so what do I know here? Well, looking at my diagram, I know that this length right here is 24 centimeters. Okay. I also know, looking at the diagram, that like from here to here is 8 centimeters. Okay. Now the significance of that is that's going to give me the height of the triangle right there. Okay. You following? I also know from over here that from here to here, that's 15 centimeters. And again, the significance of that is that that is telling me the base of the triangle, if you will. We okay with that? And then what else do I know? Over here, I'm told that from here to here is 15 centimeters. So this is 15 centimeters. And the significance of that, that's giving me the height of my rectangle or the width of my rectangle. Make sense? Okay. So the area of my base, and I'm going to write it this way, that's going to equal the area of my rectangle minus the area of the triangle. Okay. So the area of my rectangle, it's just a 24 by 15 rectangle. So that's going to be 24 centimeters times 15 centimeters. And 24 times 15 is 360. So the area of the rectangle is 360 square centimeters. Is that okay? The triangle, now I know on the triangle, I know the base is 15, I know the height is 8. So the area of the triangle is going to be 1/2 times the base, which is 15 centimeters, times the height, which is 8 centimeters. You with me on that? So 1/2 times 15 times 8, well, 1/2 of 8 would be 4, and 4 times 15 is 60. So that's going to be minus 60 square centimeters. And 360 minus 60 is just going to be 300 square centimeters. So again, that's the area of the base here. Okay. So I'm going to come up here. The volume then is going to equal the area of the base times the altitude. So in this case, that's going to be 300 square centimeters times the altitude, which is 48 centimeters. So that is 14,400 cubic centimeters. Does that make sense? So I could say there's 14,400 cubic centimeters of steel making up this V block. Okay. Now again, I want to know the weight. So if I take the 14,400 cubic centimeters, and if I know that this particular steel weighs 0.0173 pounds for each cubic centimeter, I can use a unit multiplier for that. So the cubic centimeter is going to go away, and when I multiply, that's going to give me the weight. So if I take the 14,400 times the 0.0173, that is 249.12. So this V block, the steel V block, would weigh 249.12 pounds. So about 250 pounds is what that would weigh. So pretty heavy. Make sense? Okay. So that finishes the section 9.1 notes. Okay, so you should be able to handle the section 9.1 homework. Okay. The practical applications that you're going to see there are along the lines of the things that I've seen. So what can change is, you know, like the shapes of the bases and so on, but you're still going to have to find things like how many cubic yards of concrete do you need? How many gallons is it going to take to fill up the pool? It's going to be that kind of stuff. How much would this thing weigh? And so on. Okay. Is that too terrible? Okay. As I told you last time, section 9.3 is a lot like what we've just done. Now we're skipping 9.2, right? We're not going to do 9.2. That's on things like pyramids and cones and stuff. And so you're not going to use those as a general rule, okay? You might use cylinders, okay, in your practical work and so on, okay? So, so the way this works is a lot like what we just did with prisms, except if you have a cylinder, you have round bases rather than like rectangular or triangular or trapezoidal bases, okay? So a cylinder is a solid object with two identical circular bases. The altitude of a cylinder is the perpendicular distance between the bases, okay? A right cylinder is one whose curved side walls are perpendicular to the circular base. The radius, diameter, or circumference of a cylinder are those of its circular base, okay? So if you look at the figure here, we've got a circle base at the bottom and top, okay? So again, if you look at it, it's like a prism, except it's round at the top and the bottom instead of like straight edges, okay? And then the altitude is going to be the distance between the two circles. And if it's a right cylinder, then we have a 90-degree angle between the altitude and the base circles. So 90-degree angles both here and here, okay? Does that make sense? Okay. We're going to generally be working with right cylinders, okay? Everybody okay with that? You've seen cylinders before, right? So nothing real new. Do what?
You need to have paper. Do you have a
Oh, you don't have 9.3 on
I
that,
don't
those
have
notes?
any of them.
It should have been in the same packet.
Is it? Well, it was just one. Yeah, I just had one.
What's on the back there? That's not the cylinders? Okay.
And not see it.
So the following formulas enable us to find the lateral surface area and the volume of a cylinder. We could also find the total surface area. Okay. So the lateral surface area of the cylinder is like the lateral surface area of a prism. Okay. So it's going to be like the area, you know, around the sides. Does that make sense? Not counting the top and the bottom. Okay. Now, if we were to cut that apart and flatten it, that would really be a rectangular shape. Okay. So anyway, to cut to the chase, okay, how did we do it for prisms? It was the lateral surface area was the perimeter times the height, right? Well, if it's circular, we don't really have a perimeter, we have a circumference, okay? So the lateral surface area is going to equal the circumference of the circle times the altitude, h. Does that make sense? Now, you remember, how do we find the circumference of a circle? Well, it's 2 times pi times the radius, or the diameter times pi. Okay, does that make sense? So you could think of it in any of those 3 ways. How are you going to find the lateral surface area? You find the circumference of the circle and then take it times the height of the cylinder. Okay, or if you know the radius of the circle, then you could take 2 times pi times the radius and then take that times the height of the cylinder. Or if you know the diameter of the radius, the diameter of the circle, I should say, you can take the diameter times pi and then multiply that by the height of the cylinder. Make sense? Okay. So it's really the same formula as we used for the lateral surface area of prisms, right? It's just that technically it's not a perimeter, it's a circumference. So that's the only real difference, okay? And again, you really only need to think about that formula because you already know how to find the circumference of a circle, okay? So once you know the circumference, then you take it times the height. The volume of a cylinder, by the way, if you needed the total surface area instead of just the lateral surface area, and I don't know why the textbook didn't include the total surface area formula in the box, okay? But if you need the total surface area, you're just going to take the lateral surface area and then you're going to add the bases. So you're going to take 2 times the area of the bases. Well, the bases are circles, so you have to know the radius. So pi r square is going to be the area of like the top circle, and the bottom circle is going to be the same thing. So if you add on 2 times pi r square, that's going to add on the top and the bottom, which would give you the total surface area. Does that make sense? So I wrote that right there. To find the total surface area of a cylinder, simply add the areas of the 2 circular bases to the lateral area. Okay, and so the formula for that is T is going to equal 2 pi r square plus 2 pi r h, or you could factor out the 2 pi r, so that would be 2 pi r times the quantity r plus h. Okay, so again, 2 pi r square in that formula right there, 2 pi r square is the area of the 2 circles. Like that circle would be pi r square, and you got 2 of them. Okay, and then the 2 pi r h, that right there is the lateral surface area. Does that make sense? Okay, and so add that together, you got the total surface area. And then if you're going to find the total surface area, you could make the formula a little simpler by just doing that. So all they've really done is like factored out 2 pi r. So 2 pi r times in parentheses r plus h gives you the same thing. Okay. So I don't know, this formula looks a little more complicated. It's easy to use, but you'd have to memorize it. It's just as easy to remember, oh, I find the lateral surface area and I add on 2 bases, which is what we've done before. Okay, so it's really nothing new other than it's circles. Okay. The volume, how do you find the volume of a prism? You find the area of the base times the altitude, the height. Okay, so in this case, we're going to have our bases, that's circles, right? So the area of that base is going to be the area of the circle, which is pi r square. And then you're going to multiply that by the altitude, h. So the volume is equal to pi r square times h. Does that make sense? Which again is really just the same thing we did in section 1, okay, except it's a circle. Now, if you'll remember, there were alternative formulas, okay? So instead of pi r square for the area of a circle, you could do 1/4 times pi times the diameter square. So that was an alternate formula for finding the area of a circle. So we could also say the volume is going to equal 1/4 pi times the diameter square times the height. Okay. And 1/4 times pi is 0.7854 approximately. So you could say that's 0.7854 times the diameter square times the height. So it's really all the same thing. Okay, does that make sense? Okay, so nothing really new here. Okay. So example 1. For each figure shown, find the lateral surface area and the volume. Round to the nearest tenth. We're almost always going to have to round when we're dealing with circles, right? Because pi is the 3.14159 stuff. Okay. So if we take a look at A, now we want to find two different things. We need to find the lateral surface area and we need to find the volume. So to find the lateral surface area, I need to find the circumference. Okay. Now, what I know at the moment is that the radius is 14 inches, and I know that the height is 6 inches. Okay. Knowing that the radius is 14 inches, then the circumference of the circle is going to equal pi. So that's 3.14159. So pi times 2 times 14. You with me on that? Okay. So if I punch that in my calculator, 3.14159 times 2 times 14. The 2 times 14 is to get the diameter, right? And so that is 87.96452. And that is inches. That's the circumference. Okay. Now, I didn't round that to the nearest tenth because that's not my final answer. Okay. When I get lateral surface area and volume, I will do that. Okay. So my lateral surface area is going to equal the circumference times the height. Okay. So that's going to equal 87.96452 inches times the height, which is 6 inches. So if I just take that 87.96452 in my calculator times 6, that's 527.78712. Square inches. And now that's the lateral surface area. So now I'm going to round that to the nearest tenth. So that would be about 527.8 square inches. Piece of cake. The volume. Well, to find the volume, I need to know the area of the circle. And I'm going to take that times the altitude. Okay. So I need to find the area of the circle times the height. Okay. Well, the area of my circle is going to equal pi r squared. Okay. So pi, that's 3.14159 times the radius is 14 inches squared. With me on that? Well, 14 squared would be 196. And so if I take that times 3.14159, that is 615.75164. Again, I'm not going to round that because that's not my final answer. Okay. So that is 615.75164. That should have been inches. I put feet. Okay. So this is going to be square inches. So my volume is going to equal the 615.75164 square inches times the 6 inches. Makes sense? So that is 3,694.50984. Cubic inches. So that would be 3,694.5 cubic inches if I round to the 10th place. Piece of cake. Again, I didn't round to 615.8 because if I take 615.8 times 6, I don't get the same 10th place. You with me? So I waited till the end to round. That's the general good practice instead of rounding intermediately. So like in the middle. Okay. If you do round in the middle, you're going to get rounding error in the calculation. Any big deal about those? Now, I did not directly use the formulas up here, okay? So I could have, like, for finding the lateral surface area, I could have taken 2 times 3.14159 times 14 times 6 and got that all at once, okay? I like, again, relating it to what we already know how to do, okay? Likewise, for the volume, I could have taken 3.14159 times 14 squared times 6. And that would have given me the answer all at once. You're perfectly welcome to do that, okay? I'm just, again, trying to keep the same process that we had from section 9.1, okay? So you don't really have to know new formulas. You're doing the same thing, okay? Same idea here. Now we have our cylinder, but it's laying on the side, okay? So I know that the diameter is 14 centimeters, which, by the way, means the radius is 7 centimeters. And I know the height is 26.5 centimeters. So if I want to find the lateral surface area, okay, then I'm going to need to know the circumference. Well, the circumference is equal to pi times the diameter. And so that's going to be 3.14159 times 14 centimeters. So that is 43.98226. Centimeters. So my lateral surface area is going to equal the circumference times the altitude. So that's just going to be the 43.98226 centimeters times the 26.5 centimeters. So that is 1,165.52989 square centimeters, or rounding 1,165.5 square centimeters. To find the volume, I need to find the area of the circle and then take it times the 26.6 or 26.5. So the area of my circle is, again, pi r squared. So that's going to be 3.14159 times 7 centimeters squared. Well, 7 squared is 49, and 49 times 3.14159 is 153.9791 square centimeters. So the volume of this cylinder is going to be, again, the area of the base times the height. So that's going to equal the 153.9791 square centimeters times the 26.5 centimeters. So that's going to be 4,079.354615 cubic centimeters now. So if I round 4,079.4. Almost boring because we're doing the same old thing, right? Okay. Of course, it's not boring. This class is never boring, but almost. We okay with that? Okay. Now we also have spheres. What's a sphere? Well, a sphere is just like a ball, right? Okay. So a sphere is like the three-dimensional version of a circle. Okay. A sphere is a surface whose points are all equidistant from a given point called the center. So if you picture the ball here, you got a center. And so whether you go like left or right or forward or backwards or up or down or diagonal, okay, all of the points that are on the surface of that sphere are the same distance from the center. Okay. The radius is the distance from the center to the surface. The diameter is the straight line distance across the sphere on a line through its center. Okay. Makes sense? You've seen spheres before, I'm guessing. Okay. The following formulas enable us to find the surface area and the volume of a sphere. Okay. Now we don't really have a lateral surface area on a sphere, right? We just kind of have a total surface area. So the surface area of a sphere is 4 times pi times the radius square. Or if you prefer, it's pi times the diameter square. Okay. So 4 pi r square or just pi times the diameter square. Do you see the relationship between those two? If the diameter is equal to 2 radiuses, if I take 2 radiuses and square it, that's going to be 2r times 2r, which is 4r squared. So the 4r squared times the radius square is because the 4 is coming from 2 radiuses equal the diameter. Okay. The volume of a sphere, we have 2 versions again. It is 4 pi times the radius cubed divided by 3, or in terms of the diameter, it's pi times the diameter cube divided by 6. And so again, same kind of deal. The diameter is 2 radiuses. So if you took all of that, they work out to be the same thing. Okay. So example 2, find the surface area and volume of the sphere shown. Round answers to the nearest whole unit. Okay, so no tenths. We're going to go off to the nearest 1. Okay. So in this particular figure, we have a sphere and the diameter of the sphere is 16 inches. So again, we want to find the surface area and the volume both. Okay. So since we have the diameter, so D equals 16 inches, it's probably going to be easier to use the formulas with the diameters involved. Okay. But if you didn't want to do that, if the diameter is 16 inches, then the radius is 8 inches. So you could just as easily use the ones that have the radius formulas. Does that make sense? Okay. So it's really how you prefer to do it. Okay. So for the surface area, that's going to equal pi times the diameter squared. So 3.14159 times 8 inches, or rather 16 inches, because I have the diameter. Squared. Now 16 inches squared means 16 inches times 16 inches. So we're going to get square inches, which is what we would expect for an area. Okay. Now 16 times 16 is 256. And so if I take that times 3.14159, that is 804.24704. Square inches. Or if I round that to the nearest whole unit, that would be about 804 square inches. Remember that paint problem from earlier? If we could cover 400 square, well, that was square feet instead of square inches, so never mind. But if this was square feet, then it would take just a little more than 2 gallons to be able to paint the thing. Okay, does that make sense? Probably it's close enough we could squeeze it out of 2 gallons, but okay. The volume, using the formula with the diameter in it, is pi times the diameter cubed divided by 6. So in this case, that's going to be 3.14159 times 16 inches cubed over 6. So 16 inches times 16 inches times 16 inches is going to give us cubic inches, okay, which we should get because it's volume, okay. 16 cubed is 4,096. If I take that times 3.14159, that is 12,867.95. And if I take that and divide by 6, that is 2,144.65. You with me? So I'll scoot that over. So this is going to be 2,144.658773 cubic inches. So if I round to the nearest whole unit, that's going to be 2,145 cubic inches. Make sense? A hemisphere. A hemisphere is a half sphere. Find the lateral surface area and the volume of the hemisphere shown. Round answers to 1 decimal place. So like if I were to take this sphere and cut it in half, okay, then the lateral surface area would be half of the total surface area. Does that make sense? So all I would do is find the 804 and divide by 2, okay? And the volume would be half of this volume. So all I would do is find the volume of the whole sphere and cut it in 2, okay? Now, just to be clear, if I'm talking about lateral surface area, that would just be the area of like the part under the circle here, right? That's not including the circle, okay? So if you had some kind of a shape where you needed to know, you know, like the total surface area of a hemisphere, you would find the lateral surface area, which again is just like this part down here, and then you would have to add on the area of the circle. Does that make sense? Now, I don't think you're going to have any problems where you have to do that, but if you did, for some reason, that's what you'd have to do, okay? So lateral surface area, again, I'm just saying, doesn't include the circle part, right? Okay. So find the lateral surface area and the volume of the hemisphere shown. Round the answers to 1 decimal place, okay? So the lateral surface area is going to equal 1/2 of the whole area. So that's going to equal, like in this particular case, we know the radius. So the radius is 6.4 meters. Now, by the way, that would mean the diameter is 12.8 meters. So it's not a big deal. But if I'm using if I'm using the radius, I would use the 4 pi r square formula. Does that make sense? Okay. So again, it's just half of the whole surface area. So I have 1/2 times 4 times 3.14159 times my radius is 6.4 meters squared. You with me on that? Now 1/2 times 4 is just going to be 2. So I'm going to just go ahead and punch this all in. Okay. So again, 1/2 times 4 is 2. So 2 times 3.14159 times 6.4 squared. So that all together is 257.3590528. And the units will be square meters. And so now if I round to the 10th, that would be about 257.4 square meters. Not too hard. Now again, this is the volume of the hemisphere. So that's going to equal 1/2 of the volume of the whole sphere. Okay. So that's going to be 1/2 times 4 pi r cubed over 3 using the radius version of the formula. Okay. So in this case, that's going to be 1/2 times 4 times 3.14159 times 6.4 meters cubed, all divided by 6. You with me? Now the 1/2 will cancel with the 4, leaving 2. Is that okay? So I have 2 times 3.14159 times 6.4 cubed, and then all of that gets divided by 6. $3.14159. Okay, had to correct my calculator there. And so that is 274.516323. Cubic meters. So if I round to the 1 decimal place, that would be about 274.5 cubic meters. Still nothing really new? Okay. So now we have a few practical applications. How many gallons of water can be stored in a cylindrical tank that's 22 feet high with a diameter of 14 feet? Round to the nearest whole number. Okay, so we got ourselves a water tank here. Okay, and the question is, how much can it hold? Okay, so we got a 14-foot diameter, it's 22 feet high. How much water can that tank hold? Okay, so really, what am I doing here? I need to find the volume, and then once I know the volume, I can convert that to gallons. Now, in this particular case, my diameter and my height are both given in terms of feet. Okay, so I have consistent units. If I find the volume, it's going to be cubic feet. And once I have cubic feet, then I can convert that to gallons. Because we know that 1 gallon or 1 cubic foot will hold 7.48 gallons. That was given in the previous section's notes, okay, which you'll be able to use, okay, that fact you'll be able to use, okay. When it comes to the test, by the way, like I did on the last test, I'll give you those conversion fact things so that you can you have those available, okay. So in order to find the volume, I need to know the area of the base, so the area of the circle, and I need to know the height, okay? So what I know right now is that the diameter of the circle is 14 feet. So that means that the radius of the circle is 7 feet, okay? And I can use that to find the area of the circle, okay? I also know that the height is 22 feet, okay? So the area of the circle, again, is pi r squared. So in this case, that's going to be 3.14159 times 7 feet squared. Now 7 squared is 49. So 3.14159 times 49 is about 153.93791. Square feet. So the volume of the tank is going to equal the area of the base. So it's going to equal 153.93791 square feet times the height of the tank, which is 22 feet. So if I take that times 22, that is 3,386.63402 cubic feet. Y'all okay with that? So again, really the only difference between that and what we did on like the previous examples is that we're figuring out how many gallons, okay? So it's not a whole lot of difference, okay? Now from the section 9.1 notes again, I know that 1 cubic foot will hold 7.48 gallons. So if I take the 3,386.63402 cubic feet, and if I use the multiplier 1 gallon, or rather 7.48 gallons in 1 cubic foot, that's going to cancel out the cubic feet. And so I just need to multiply by the 7.48. So this number times 7.48 is equal to 25,332.02247 gallons. And our directions said to round to the nearest whole number. So that would be about 25,332 gallons. So quite a bit, right? Not as much as that swimming pool on the previous on the previous notes. You know, that was 47,000, right? So it would take almost 2 of these tanks to fill up the swimming pool. We good? That's a pretty big tank. Okay. Of course, it was a bigger pool. Example 5. So again, I mean, would you agree that's really not any different from the pool problem? Example 5. If a gallon of paint can cover 180 square feet of surface, how many gallons will be needed to paint the top and side of a cylindrical tank from example 4? Assume you cannot buy a fraction of a gallon. So the same tank, but we want to paint the top and the side. You with me? So now that's not really just doing the lateral surface area. It's also not doing the total surface area, okay? Because we're not going to paint the circle on the bottom, right? We're just going to paint the circle on the top and we're going to paint the side, okay? So we need the lateral surface area plus one circle, one top, okay? Does that make sense? So the lateral surface area, I need to find the circumference of the circle, okay? Well, I know the diameter is 14 feet. So that means the circumference is going to equal 3.14159 times 14 feet. 3.14159 times 14. That is 43.98226 feet. Okay. So the lateral surface area is going to be the circumference times the height, right? So that's going to be 43.98226 feet times 22 feet, which is the height of the cylinder. So that's 967.60972 square feet. Is that okay? I also need to find the area of the top. Well, the area of the top, I know the diameter is 14, so I could use that version of the formula. But if the diameter is 14, that means the radius is 7, right? So pi times the radius square. So 3.14159 times 7 square, 7 feet squared. Actually, we did that up here. That's 153.93791. Is that okay? So the area to be painted is going to equal the 967.60972 square feet plus the 153.93791 square feet. So if I add that together, 967.60972 plus 153.93791, that is 1,121.54763 square feet. So we need to paint that many square feet of surface. Now for the paint that we're going to use, 1 gallon only covers 180 square feet, okay? So if I take the 1,121.54763 square feet, and if 1 gallon covers 180 square feet, you with me? Then really what I'm going to do is divide by 180. So that is 6.23. So I'm really going to need about 6.23 gallons. But again, it said that we can't buy fractions of a gallon. So we're really going to have to buy 7 gallons. Does that make sense? We can't just use normal rounding rules, right? Because if we use normal rounding rules, we'd have only 6 gallons and we'd run out of paint before we got the last little bit painted. Okay. Too terrible? One last problem for this section. The metal silo shown has a hemispherical top. How many bushels of grain would fill the silo to capacity? Round to the nearest whole bushel. Okay, so we've got this silo. And so notice the silo, it's like a cylinder, but then it's got a hemisphere on top. Okay. We got an 18-foot diameter, and from the bottom to the tip of the hemisphere is 38 feet. You with me on that? Okay. So our question is, how many bushels of grain could we put in that silo? Okay. Now, so really what I'm going to have to do is I'm going to have to find the volume. Does that make sense? And once I have the volume, I could maybe use back here. I know that 1 cubic foot is equivalent to 0.806 bushel. So a bushel is a little bigger than a cubic foot. Does that make sense? Okay. But I can use that in order to convert and learn how many bushels I'm going to be able to hold. Okay. So there's a little bit of a trickiness on this problem. Okay. First of all, I know the diameter of both the cylinder and the hemisphere is 18 feet, which means the radius is going to be 9 feet. Would you buy that? So if I asked you how tall is the cylinder part? So in other words, the 38 feet goes all the way from the bottom to the tip top of the hemisphere. If I just went to the top of the cylinder, how high is that? How far?
20.
Where'd you get 20?
Oh, no.
Would you subtract 18?
No,
You subtract 9. Okay. So like if I picture in the top here of my hemisphere, the radius there is 9, which is also the same as the, like from the center to the top, right? So if I take 38 feet minus 9 feet, that's going to be 29 feet is the height of the cylinder part. Does that make sense? So what I'm going to do here is I'm going to find the volume of the cylinder part, and I'm going to find the volume of the hemisphere part and add that together, and that'll be the volume of the silo. Okay, make sense? So the volume of the silo is going to equal the volume of the cylinder plus the volume of the hemisphere. Okay. So how do I find the volume of the cylinder? Well, the area of the base of the cylinder is going to be pi r squared. Okay. And then I'm going to take that times the height of the cylinder. And the height of the cylinder is 29 feet. Okay. So in this case, that's going to be 3.14159 times 9 feet squared. That's the area of the circle, right, at the bottom of the cylinder. Okay, so 9 squared is 81, and 3.14159 times 81, that is 254.46879. So the volume of the cylinder is going to equal the area times the height of the cylinder. So the volume of the cylinder is going to be 254. 254.46879 times the height, 29. I didn't write down the units like I normally do. It's that many square feet times 29 feet, so it's going to be cubic feet. Okay, so taking that times 29 is 7,379.59491. And again, that would be cubic feet. That's the volume of the cylinder part. We okay? Now the volume of the hemisphere part. Okay. Well, I know the radius is 9. Okay. And if you remember your formula here, the volume is 4 pi times the radius cubed divided by 3. My radius is 9. Okay. And we're going to do half of that because it's a hemisphere instead of the whole sphere. Okay. So 1/2, because it's a hemisphere, times 4 times 3.14159 times 9 feet cubed divided by 6. Again, I hope not divided by 6, divided by 3. It's 6 if I'm using the diameter, but I don't have the 4 if I'm using the diameter. We okay with that? Okay. So again, the 2 and the 4 is going to cancel. So I really have 2 times 3.14159 times 9 cubed, and then that all gets divided by 3. So that is 1,526.81274 cubic feet. You buy that? So if I add those two things together, so, well, I've got the 1,526.81274 in my calculator already. So I'm going to just leave that there, and I'm going to add the 7,379.59491. So that's 8,906.40765. Cubic feet. Is that okay? So that's the volume. But the question was, how many bushels of like corn or beans or whatever could I put in there? Okay. So 1 cubic foot is the same as 0.806 bushels. Okay. So if I take the 8906.40765 cubic feet, and if I use a unit multiplier, again, 0.806 bushels in 1 cubic foot. So cubic feet will cancel, and I just got to multiply this by 0.806. So that is 7,178.56. So 7,178.56 564,566 bushels. And it said round to the whole bushel. So that would be about 7,179 bushels. The truth is, I really probably should round down, because if this is the maximum capacity, I don't really have any room to cram that extra little bit here. Does that make sense? So really, I should probably round down instead of up and say 7,178. Okay, does that make sense? Okay. Just because if literally that's the capacity, then I couldn't go up to 79. That's a little bit too much. It'd be spilling out. Okay. Any questions about that? So again, a lot of what we did right there was the same as what we did at the starting of the class, right? To finish up section 9.1. Okay. So not a whole lot of difference there. So you should be able to handle the section 9.2 homework, and you should be able to handle the that's 9.3 technically. And you should be able to handle the chapter 9 quiz. Okay. So all we're doing in chapter 9 is section 1 and 3. So you got the homework for 9.1, the homework for 9.3, and then you should be able to do the chapter 9 quiz, which just mixes it all together. Okay. Really, there's not a whole lot of difference between the questions on the quiz and the questions on the 2 sections. Okay. So next time, I'm not going to start it today, but next time we're going to start chapter 10. Like we did here, we have 2 sections. Like we did in chapter 9, there's 2 sections that we're going to cover. So we got 2 weeks left, right? And we got 2 sections left to cover. So the way I'm kind of visualizing this coming out, unless something goes wrong, we'll probably cover 1 section on Monday, right? That's section 10.1. We'll cover 1 section on Wednesday. That's section 10.2. Okay. Talk about the test. Okay. Which is going to cover chapters 8, 9, and 10. So what was chapter 8? That was all like the area and perimeter stuff for all the different shapes and so on. Okay. So that, and then the prisms, and now the cylinders and the spheres and hemispheres and so on. And in chapter 10, we're going to be looking at trigonometry. It's like an introduction to trigonometry. Okay. Sounds worse than it is. Okay. So trigonometry is just like the study of triangles. You already know triangles a little bit. So we're going to be looking at some specifics of triangles. Okay. And we'll be talking about, well, I'm not going to get into it right now, but we'll be talking about how relationships with triangles tend to hold. Okay. And so we can figure things out and so on. Okay. Anyway, so we'll be looking at that next time. I'm going to go ahead and give you the handout so that you have possession of it, not me. And so again, we're going to just stop here today, just a couple of minutes earlier than normal, but we'll stop here today and we'll pick up with chapter 10 next time. I think you got plenty of homework to do, so we won't start chapter 10 just yet. Okay. Have a good rest of your day.